line L is tangent to the graph y equals cosine x at the point k, x equals k, y equals cosine k from 0 to pi. For what value of k does the line L pass through the origin? Holy cow, so much to break down. First thing I'm going to do, and I didn't do this when I did the problem, but first thing that I recommend doing is graphing this out to get an idea of what's going on. So first thing I'm going to do is graph cosine x, and I'm only going to graph it in that domain that was given. Okay, and the domain that was given was 0 to pi. So I'm going to show you how to do that. Hit window, and then change your x min to 0, and your x max to pi. You have to know how to do this. You have to know how to do this because there are some problems. The only way you're gonna be able to solve them is if you mess with the window setting so you can see what you're actually looking at, okay? It will greatly help you to do this. Okay, then hit zoom 0, and what zoom 0 does is it fits it to the screen so it looks all pretty. Look at how pretty that looks. That's insane, okay? Now, what we're doing on this is we're trying to get an idea of what we're looking for. There is some line L that if you made that tangent line from that graph, so there's some tangent line, just remember it's grazing one point, and it has to go through the origin, it said. So try to imagine that in your head. I'm going to draw this out with the screenshot, but you could have also just drawn cosine x as well if you want. You don't have to base it off your calculator because it's kind of an easy graph. You've all taken pre-calc, so you should know what that graph looks like. Okay, so can anyone give me a clue on where I can even draw this line L? Where does it have to be so that the tangent line goes through the origin? Just give me like a ballpark of where it would be. Less than 1, less than 2, or in between 1 and 2, greater than 2. Where would it be? Does anyone have any ideas? So we want to graze this point here. Oh, wait, did someone write something in the chat maybe? I'm going to use my old ruler here. We want this to go through the origin. I'm just doing this so it's straight. It doesn't matter how you sketch it. But to make a tangent line that goes through this graph, it would have to go through basically this line, or this point right here, I should say. Not through it, but grazing it right there. Okay, so we are looking for what value, this is our k value right here that we need. Does that make sense? Okay, the problem is might be a little bit easier to solve now once you know that, because this is probably one of the hardest things right here to understand what we're even looking for. Now, it made it a little bit easier by saying it's going through the origin, okay, but it really could have said going through any points, 1, 1, 0, 1, doesn't matter. Could have been going through any point, but it just goes through the origin. Okay, well, what we're going to try to do is we're going to try to make an equation of that red line that I just drew there, that tangent line. Okay, I mean, there might be other ways of doing this. I guess first thing I should do too is this obviously eliminates some of these answers. It can't be this one because 0.86 is like right here. That would clearly not go through the origin. So it's definitely not A. Okay, 1.57, that's like right here. Okay, as you can see, that would definitely not go through the origin if I made a tangent line there. So it's definitely not B. Definitely not B. It could be 356, I'm sorry, but it looks like it's past the 2.5 mark, so I really doubt it's that, but maybe I'm not being exact here. D actually is the correct answer, in case you care. There is no such value of K. There totally is, because you can see it in the graph. There is a value that exists. So right now it's between C and D, but without even doing any work, like any math work, you could actually see that it would be D anyway, but let's work it out just in case a free response problem is similar to this. Okay, so what we're going to do is we're going to make an equation of this tangent line right here, and it's going to be y is equal to mx plus b. What's cool is the b is 0, so that's gone. The m, well, what's the slope of this? Well, the slope of any points on this line is going to be equal to sine of x. Oops, that's embarrassing. Negative sine of x. Now, how do I know that? Because the graph is cosine x. The derivative of that is negative sine x. So I can plug in any x value to that equation right there in yellow. Any x value I want, and it tells me the slope at that point. Okay? We don't actually need the slope for this one. We need the k value. So we want to find the slope at k, essentially, because we need the equation at k. So that's what I'm going to do. I'm going to plug in a k, so it's y prime of k, into this equation, and you're going to get negative sine of k. So that means if I was making a equation of a tangent line, it could be y is equal to, the m is negative sine k, negative sinc, times x plus 0, okay, because the b is 0. So now we have an equation for that line, right? Well, it needs to go through this point right here. It goes to the origin, awesome. I got rid of the b. The origin doesn't help us. If you plugged in 0, 0 here, you'd get 0 equals 0. That doesn't help. But you can use the k comma cosine k to solve this, okay? So our x is k and our y is cosine k. So check this out. Cosine k is the y. Again, it just says that up there. Cosine k is the y. And the x is k as well. So now it's negative sinc times k. But we need to solve for k, and this is impossible to solve algebraically. So guess what you need to use? Your calculator. Okay? So we are going to graph cosine x on one side and then negative sine x times x on the other, and we're going to see where it intersects. You cannot use k in your calculator. Ooh. You cannot use k in your calculator. If you did, it would treat it as a constant. The only thing that it treats as a variable is x when you're in the y equals menu. So if you try k, it will not work. It's going to default whatever value k, the variable, is in your calculator already. So do not do that. You have to use x. That being said, say that was a different letter like y or b or a. You would still have to use x on your calculator because your calculator is programmed to only do the x. Okay, I'll show you what I mean here. So we're going to go in here. You cannot write cosine of k. Okay, it will not graph it out. Where's the k? Right here. Okay, let me just show you. It just graphs it as a constant. I'm assuming it took k as 0 because I've never used k for anything, but let me try it really quick to see what's going on here. So let's try k. I have it as 0. So it did cosine of 0 and it graphed it as 1. It doesn't understand that really we want all these other different values of x throughout. Okay, whoever programmed this calculator, that's the rule they made for whatever reason. Okay, so we have to make it into an x, long story short. It doesn't matter what the letter is, A, B, C, any letter you can imagine, you have to do it as x. Okay. We want this set equal to the other side of the equation, which is going to be negative, excuse me, it's going to be negative, that's embarrassing. Wait, why did I do second? Oh my gosh, negative, sorry, negative x sine x, okay? And we want this to be still between 0 and pi, which, oh, it already is, nice. And then I'm going to do a zoom 0 so it fits it to the screen. So we have the cosine, and then we have this, the negative x sine x there. And clearly there is an intersection point, which is similar to the other graph that I drew, where that intersection happens. All right, and then you can do second calc 5, enter, enter, enter. There's only one intersection, and it's going to find it, negative 2.798. Okay? Your brains should be doing this right now. That is insane. There's so many concepts. That's why I said welcome to AP. This is a AP style problem because it involves concepts. It doesn't look like every other problem you've ever seen. It looks similar, but there's so many other concepts you have to draw on to be able to get to this point. Okay? Now, you are not expected to solve a problem like this every single time. That's why there's such a curve with AP. Okay, you don't necessarily need to get all of these right to get a 5. You can get some of these wrong. There's a lot of them that are just procedural problems where it's like, find this derivative, find this antiderivative. And then there's some where it's like, find the value of k such that the tangent line at line L that goes to the origin, makes that true for y equals cosine x. Like that's a crazy problem. That's crazy. But hopefully you like that. Even if you get it wrong, I hope you still like it. Because there's some people that are like, I got it wrong. This is stupid. I hate this class. But like, you like try to like stuff even if you get it wrong. Like a lot of people just like things they're good at. But just, I don't know, just a lot of learning in this.